Hello, welcome to Astronautics for Exploit. This is Dr. Ayeshola Ogundele. Satellite constellations, innovative approaches for next-generation communications, navigation, space-based computing, and artificial intelligence. Satellite constellation, a network of artificial satellites working together in unison and coordinated fashion to provide continuous and global coverage. In contrary to a single and expensive satellite designed to perform an isolated task, has been receiving attention for several decades from government space agencies and private space companies based on its numerous advantages. In order to achieve uninterrupted or near-uninterrupted services, constellated satellites are deployed into meticulously designed and planned orbital planes. The type of orbit chosen for the constellation is a function of the purposes the constellation is expected to achieve. Examples of satellite constellations orbits are low Earth orbit, medium Earth orbit, geostationary Earth orbit, and hybrid orbit. Low Earth orbit, with altitude of 160 to 2,000 kilometers, is chosen for some constellations because of its proximity to the Earth, which allows for low latency, essential for services such as high-speed broadband internet. Because they cover a smaller area, many more satellites are needed in order to provide continuous global coverage. Medium Earth orbit are used for some satellite constellations, primarily for navigation, including Global Navigation Satellite System, GPS, and Galileo. Because GEO appear fixed in the sky, geostationary Earth orbit satellite constellations provide widespread coverage, making them ideal for telecommunications and weather monitoring. Hybrid constellations, such as O3b system, combine satellites in different orbital altitudes, such as LEO and MEO, in order to optimize services. The focus points are as follows: satellite constellations, evolution of satellite constellations, type of satellite constellations, and challenges of satellite constellation. Satellite constellation is a network of artificial satellites working together as a single system to provide continuous global coverage for a specific service. By using multiple coordinated spacecraft, a constellation can provide broader and more reliable coverage than a single satellite. Satellites are placed in sets of complementary orbital planes and connect to globally distributed ground stations. Unlike a single satellite, a constellation can provide permanent global or near global coverage, so that at any time, everywhere on Earth, at least one satellite is visible. Illustration of the use of small satellites for geostationary communication is shown in this picture. Continuous service. A satellite constellation can ensure continuous service by using multiple satellites in different orbits. Examples include GPS constellation and mega constellation of Starlink and OneWeb. Inter-satellite communication. Satellite mega constellations consist of hundreds of thousands of spacecraft, and they are becoming popular solution for global communication coverage. Illustration of satellite mega constellation is shown in this picture. Evolution of satellite constellations. Early satellite constellations were limited in scale, expensive, and primarily developed by governments for military and scientific purposes. As early as 1945, science fiction writer Arthur Clarke theorized about a constellation of 3 satellites in geostationary orbit that could provide global communication. The first constellations in the 1960s were deployed to establish basic communication links. Examples are Telstar 1962 and Monia of 1965. Eutelsat multi-orbit GEO-LEO satellite network is shown in this picture. 20th century satellite constellation. This early communication satellite constellation operated in a non-geosynchronous orbit, providing intermittent transatlantic signal availability for just 30 minutes in each 2.5-hour orbit. Monia, the Soviet Union launched this constellation in order to provide continuous coverage over high latitudes, which were not served by geostationary Earth orbit satellites. Telesat Lightspeed constellation is shown in this picture. The 21st century satellite constellation. The 21st century usher in the new space era, characterized by an explosion of commercial activity and the development of large proliferated constellations. The development of reusable rocket technology pioneered by SpaceX Falcon 9 drastically lowered the cost of deploying satellites. Advancement in manufacturing also enabled development of smaller satellites. Illustration of satellite coverage for telecommunication services is shown in this picture. Types of satellite constellations. The different types of satellite constellation are GPS. The Global Positioning System uses a constellation of about 24 of large satellites in medium Earth orbit for the purpose of navigation and positioning. Iridium provides global voice and direct coverage for satellite phones and other devices with 66 active satellites in low Earth orbit. Starlink is a mega constellation with thousands of satellites in low Earth orbit. Orbital design optimization for large-scale SAR constellation is shown in this picture. Other examples of satellite constellation are Landsat. Landsat A and 9 satellites work together as a constellation, orbiting at different times to provide complete global imagery every 8 days. Military communications. Constellations such as Defense Satellite Communication System support military communication needs globally. OneWeb, the company aims to deliver a global broadband network using hundreds of LEO satellites. In-orbit target-based autonomy for enhanced stability of the small satellite constellation is shown in this picture. OneWeb aims to deliver a global broadband network using hundreds of LEO satellites. Project Kuiper, Amazon's planned constellation of thousands of LEO satellites, is designed to provide high-speed internet access to underserved communities around the world. Earth observations, companies like Planet and Mazar use constellation of small satellites to provide high-frequency, high-resolution imagery for a range of applications. Illustration of the use of artificial intelligence in transforming geospatial intelligence is shown in this picture. Challenges of satellite communication are increased collision risk, collision avoidance, and astronomical interference. Mega constellations of bright satellites can interfere with ground-based astronomical observations. Satellite constellation for the mitigation of environmental and other effects is shown in this picture. Other challenges and future trends are management complexity, limited spectrum and interference, and data processing and storage. Faster space relay communication concept for multi-orbit mission is shown in this picture. Regulatory and economic orders. Satellite constellations operate beyond national borders, requiring coordination and compliance with the complex and evolving international regulation. High cost and funding. Developing and deploying a large constellation involves billions of dollars in investment. Market competition. Companies face strong competition, especially from SpaceX Starlink. Illustration of proliferated constellation is shown in this picture. Launch and re-entry emission, rocket launches, and the atmospheric re-entry of satellites at the end of their lives produce emissions which can impact our atmosphere. Ensuring long-term sustainability of space operation requires development of more sustainable launch technologies. Illustration of low Earth orbit satellite constellation is shown in this picture. For more information, contact Astronautics for Exploit. You've been listening to Satellite Constellations, Innovative Approaches for Next Generation Communications, Navigation, Space-Based Computing, and Artificial Intelligence by Dr. Ayinsola Ogundele, with a focus point, satellite constellations, evolution of satellite constellations, types of satellite constellations, and challenges of satellite constellation. Thank you.